Hello world. What's up, concurrent viewer 1 person, whoever you are out there. If you have any questions, feel free to hit me up in that chat. Yeah, let's just show you guys what's going on. Basically, over on GitHub, if you head over to GitHub, I created a repository. I'll just go on there real quick. I created a repository where you can grab this code and start from right now if you really like to. So just go to my GitHub. I think I put the link in the description, and you can go to it's Snake 3.0. There's no such thing as Snake 1.0 or 2.0, but who cares? We have Snake 3.0, and you can just clone, download that, and then pull it. You can fork it if you want. You can do whatever you want. And this is the code, so enjoy it. This is going to be pretty short. I didn't put too much charge on my computer, and it dies really quickly. So it's got 45%. We'll see how far that takes us. But I'm hoping to at least have some sort of a snake drawing on the screen by the end of this episode, or whatever it is. Not even an episode. Let me get rid of this. Let me go here. Let me see if there's any questions. Okay. So yeah, basically, let's go back into our code and start coding some stuff. This is the wrong code. So right now, if I press play, we should have a snake on the screen, and this snake just kind of squirms around. He doesn't operate like a normal snake. He has full movement freedom. He can move wherever he wants on this grid. That's really easy to fix if you want to make it more of a snake-like thing. All you need to do is where we're doing the do update in snake, just go -1 divided by, well, we're moving on the x-axis, so we can go game settings dot grid cells wide. You see, so it's one, say it's 10th or 1/40th or whatever your grid cells wide. You just throw that in here. Actually, I just need this whole one, and I'll replace this entire little thing right there, this entire thing right there, this entire thing right there. And I think I haven't actually messed with this at all since last time, so I don't know what's gonna happen. This could blow up my house right now. I have no clue. And if we move it, yep. So now it's moving on these in each individual square, which is pretty sweet. It's a really fast little guy. You can slow that down if you want by multiplying the final value of this by maybe game time dot delta time. Maybe no, probably not. We're not going to do it that way. What we are going to do is we're going to create, so we have a snake, but the snake is going to be the whole snake, and the snake is going to consist of many like snake body parts. So every cell on our grid will be filled up like with a snake body part. So I'm going to create another class under snake, and I'm going to call it snake body. And so this is going to be a game object, and the snake body is going to take an initializer. And yeah, I don't know what that's going to do yet. Let me make sure that works. Failed. I need to overwrite. Okay, before I do that, I did think of one thing, and that's the scale. So currently this is scaled down to be in 1 square, but the grid line width is technically only one side of the line. So the grid line width is like 1/2, and then the other half is also a grid line width. So the grid line width is actually like 2 grid line widths put together. So we need to multiply it by 2, and that'll make it fit nice and snug inside each one of these squares. Let me make sure I'm not talking entirely to myself. Okay, whoever's out there, you know, I feel you. I feel you out here trying to learn some snake. Some people come and view this, so yeah. So now you see it fits in there nice and snug. Yeah, that looks a lot better. All right, so yeah, let's create these snake body parts. I'm going to create a function inside a snake and call func add region, add body. Call it add body. And all add body is going to do is it's going to add it wherever the hell it needs to add it. So let me think. Yeah, so snake body. We're actually not controlling the snake body when we move. We're controlling the current movement, because if we were to just take our hands off the keyboard, our snake's going to move freely, like in the direction that we were last going. So yeah, that's something to note. I'm trying to think of the best way. We're definitely going to want to scale it, so we need to scale it exactly the same way. We'll set the position. Why is that? That's the Z position. Yeah, so the Z position will need to be set in the same spot. We need to call super.init. And then when I call add body, I will just say add child. Let's just create a let body equal body, snake body, I guess. That's what we called it. Snake body part, and I don't have any auto completion. Oh yeah, there's nothing. So if I just add this body and press play, not press play, stop it, get rid of this code right here. For snake, just go add body. The do update, we can keep that the same. Yeah, let's keep it the same. And press play. See what happens. Just want to see. Cool. Cool. There's your body. There's your snake body. Now we want a way to set the body's direction. You know what? I think what we need to do next is we need to make it so it ticks once per however fast we want the snake to go. So a really good way to do that would be to make a var up here called can_tick. That's going to be a float. Let's make it an int. And we're going to return on the outside. I keep saying we're going to go private var. We're going to call this time ticked. That's going to be an int, and that's going to be equal to 0. And I'm going to say if time ticked is greater than, let's say 60. That'll be 60 frames. So if we're doing 160, we're doing 60 frames per second. That should take 1 second. If time ticked is greater than 60, we should return true. But we should also set time ticked equal to 0. Else return false. So if we call that in our do update, if can tick, then we can move. Now also we will, this needs to return a boolean actually. Also we need a way to say like private var the next direction. So I'm going to create a private var next direction. That's going to be equal to a float 3 0 0 0. So we need the ability to control which direction it's going next. This could be a float 2, but I mean we use float 3 since this system's built out for float 3, moving on the z-axis. So the next direction, let's just say that's 1 in the positive 1 in the x direction. And then I will say here, I will say self.move that. We'll go set position move x. Should we set the position or move x? We can just move x. That's fine. We're going to move 1 divided by that. Yeah, that should do it. In the next direction. So this needs to be 1. It needs to be 1 divided by that times the next direction. Oops. If you have questions, reach out. Let me know. So if can tick, it should move in that same directions. Cannot convert type float 3 to expected float. So we need to move. We don't need to do move x. We need to move in the float 3 direction. We have an error. Let's find out where that error is. So when I add this body, really the body is the head. So I'm going to create a private var head here. And that's going to be a body part. And then I'm going to instantiate that here. So I'm going to say head equals snake body. We're going to add the head. And then I will go head.move. Yeah, snake body. Cool. Any questions? No question. Okay. We have an error. Where's this error occurring? It's not really showing me anything. If I go to here, parameter 2. Yes, there we go. Parameter 2, move that times next direction. Argument 2, what are you talking about? Okay, we're going to take this out. We're going to look at this move function. Move takes in, oh, I see. So let me real quick go to the move function. Node.move. Apparently we need a func move. Thought I added everything, but this just needs to be a value float 3. Then we'll go self dot position plus equals value. Cool. And now we have this move function, and we should be able to just go back to where we were, and it should be fine because it wasn't taking in a float 3. It was taking in an x, y, and a z. It wasn't taking in a float 3. So if my calculations are correct, once a second. Oh, nope. Sorry, this is gonna move forever. We need to else time ticked plus equals 1. Ha. Got it. Gotcha. Man, the computer is so loud. I need a drink. Let's see here. Look at that. So once a second, our snake is moving across the screen. Now, how we can control the next direction that he moves? Well, that's not so hard. Let me just kind of go back real quick because there's some code that I deleted that I shouldn't have. Look at this. I can take this keyboard input code, go down to the do update, and right there, add it right there. Now, I won't move X, but I will set the direction in which they're supposed to move. So if the key is pressed, I can say self.next direction equals, float 3, and then I'm just going to copy this. Boom, 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 and now our next direction will be updated. So if I press left, I need to go -1. If I go right, I need to go 1. If I go up, it needs to be +1. If I go down, it'll be -1. See that? Questions? Anybody? No questions. You concurrent viewers. Probably my mom. What's up, Mom? Love you. She's so sweet. Just kidding. Whoever you are. Yeah, so now, I think if I press left, should come back. Yep, there it goes. So now we have the ability to control the direction in which this snake goes. That's fine, but we want to be able to control like how fast it goes. Let's make him go a little faster. So over in game settings, I'm going to go and add a public static var snake speed. So right now we're currently doing 1/60, but we don't have to do that. We can do 1 every 1/5 of a second, or yeah. So I could either make this a float. No, it's an int. We need to make it an int. So I'm just gonna do like int equals. Let's do 10. So 10 times per second, right? So so 10/60. So what I need to do is I need to go snake, and instead of doing greater than 60, we can go greater than So if I do 10, that'll be 10 times. Yeah, 10. Yeah, so we'll go game settings dot snake speed. I don't think that'll move. This will move fast as hell, but 10 times a second. Yeah, I guess 10 times a second. Oh yeah, there we go. Okay, cool. So we have the ability to speed up and control which direction it goes, and hopefully that looks great on your screen. So what I'm going to do is I'm going to push that code up real quick so you have a cool little moving snake. So snake movement. You could also, one thing that I'm not doing here is instead of making it like tick one at a time, you could technically make it just flow like one to the other, and then keep track of which cell it's in based on, you know, like its relative position and viewport space. But I don't want to do that. I just want to make it move kind of quick because it's easier to code. To be honest, it's just easier to code. Cool. Now, so we have the ability to add that. I'm going to not move. I'm going to remove the move, and we need to be able to add more body parts. So when I call add body, let's say I say add body again. Now what I want is I want my snake, gosh, I can't spell. I want my snake to be 2 body parts. And if I add a third one, I want it to be 3. So what I'm going to do here is I'm going to set head equal to nil. And then when I add body, I'm going to say if head equals nil, then we need to create the head. Okay, so the first thing I'm going to do, I'm just going to go var body. This is going to be a snake body. I'm going to set that equal, no, we'll just do that. Now, if head equals nil, I'll go body equals snake body, and I will add the body. And also, since it's a pointer, we can go self.head equals body. And hopefully, hopefully we can still control the head. So if I, if I get rid of this head.move, get rid of this add body shenanigans, then we should still be able to control the head. Yeah, so we can still control the head, but we're generating a body at the very top. What that allows us to do now is to say else. Let's create a body. So based on, if we're going right on our screen, we need to add here. Let's go back to our grid. Let's just talk about it real quick before we do it, so we can get it solid in our heads. Yours and I, you, the only man / woman, mom out there. All right, so right now we currently have a head. If I add a body part, I want to add it right there. Correct? So, and then if I add another body part, I want to add it right there. And if I'm moving right, I want to add it behind me. If I'm moving down, I want to add it in this direction. I want to put it right up here. If I'm moving left, I want to put it behind me on the other side. So based on the direction that I'm going, that's where we're going to add it. And so since the next direction is, well, it's our head's next direction, but our head is also our tail right now. If you think about it, our head is our tail, and the tail is the head because there's only one part. So what I'm going to do is I'm going to go private var tail, because we're also going to need to be able to keep track of the tail, because the tail, the direction that the tail is going is really, really important, because that's where we're adding our next body part. So if our head is nil, self.head equals body, and self.tail equals body as well. I know. But say we were to add another body. In this case, let's just go var position. Actually, you know what? We need to set this thing's position. So let's go and add a function, private func get next position. So based on the position of our tail right now, that's where we're going to be placing it. So if tail dot all right, so our body part is going to need to have a direction. So var current direction, and I could make this a like private variable and just do a getter, but I'm not going to do that. This is a simple snake game. You guys just want to see snake. So here we have current direction equals float 3 0 0 0. I will put in the initializer, get rid of the override. The initializer, I'll put a current, or how about next direction float 3, and then I'll say self dot next direction equals next direction. So now the snake body will have a direction, because all the body parts of our snake needs to move independently of one another. I know it follows the person in front of it, but it still is going to move independently, and I'll show you why as soon as we get into like the snake, movement aspect of it. But we will need to keep track of the current direction. I didn't mean to do that. I meant to go, let's do next direction, because that's when the tick happens. That's when we're going to actually move this thing. And so if I build, that should be fine. And up here at this body part, this is going to be just self dot current or next direction. Cool. Yeah, let's get rid of this little function real quick. I want to make sure we're iterating these. So we're adding that, and looks like next direction. Oh, yeah, I should probably add that. All right, so here we go. Boom. So we have our next direction, and beautiful. Any questions? No questions. Okay. So now we have our snake's body, which is the head and the tail, and if I press start, it'll work. The problem is we're not actually making each individual body part move. So for the snake body, I'm going to create a func. I'm going to call move. Move will move in a direction. Make sense? And that direction that it moves is going to be this direction. So we'll have this move function. We'll just call self.move, and it'll be based on the next direction. When we want to turn, when we want to go in a different direction, we need a function called set next direction, or how about turn, which will take in a direction float 3, and we will say self.next direction equals direction. And then once it, ticks around, we're going to hit this move function. And how I'm going to do that is in the do update. If can tick, we can move. I'm going to create a private func here, and I'm going to call it get input. I'm going to store all this crap up there, and then I'm going to put that inside of here. So get input. If can tick, we need to move all of our children. So for child in children, child, if let, so we need to cast this thing as a snake body. If let snake body equals child as snake body, then we will go snake body dot move. Oops. Snake body dot move. Turn. Yeah, so now we have a snake body. I need to also, so if head, so self dot head dot next direction does not equal next direction, we need to turn. So say the head's direction changes, say like our current, our like we press an input and our next direction changes, and the head's direction isn't that same direction, Now we need to turn. So I will say for nope, I will say snake body dot turn, which is the next direction. I'm trying to think. This logic's just a little flawed because we're taking it. So if snake body dot next direction does not equal next direction, then we need to turn just the head. Actually, we need to go head dot turn. Yeah. I'm trying to think. So if we can tick, if head's next direction. So if I press play, what happens? Let's see what happens. May as well try it out, right? Alright, so this should still break everything. Oh, else head dot move. Else snake body dot move. This shouldn't just be move. This should be called tick, or how about slither? It is a snake. So it can either turn or it can slither. And instead of doing head dot turn, we will go snake body dot turn. But the problem is now, if the ID equals head, then I can check it. I don't need to do that inside. Oh yeah. See, it like kind of freezes up. You see that? That's not good. It's not supposed to freeze up. And I think it's because the head's next direction has nothing to do with this next direction. So we need to turn the head. If can tick. If can tick. If the head next direction does not equal next direction. Snake body dot turn. Head dot turn. So we're going to turn in the next direction for the head. And then we can say snake body dot slither. We also want our snake body. We also want to slither ourselves, right? So head dot slither. And then all of our children, we need to slither them. They also need to slither. So, oh man, look at that. It's like jumping around. Not a big fan of this. What happens if I just go like this? Ah, because the head is a child. Nope, this should be fine. So if the head's next direction does not equal the next direction, yep. And look at that. It doesn't like freeze up when we're and technically we're not supposed to go back in the other direction, so I'm going to just kind of fix that real quick. And the way I can do that is I can just say if the head direction does not equal the next direction, and self dot head dot next direction does not equal the negative, so the inverse, or actually if the next direction, you can just say next direction does not equal the inverse self dot head dot next direction. So now we can't actually go backwards on ourselves. We can only go forwards and turn in other directions, not the opposite direction that we're going. So yeah, so now you shouldn't be able to go what direction. So now, yeah, look at that. We kind of have a snake slithering around. Look at it go. Moving around the screen. It can go off the screen, but that's okay. We'll fix that. That's not too bad. Let's see if you have any questions. Nope. That one person does not have any questions. Let's see here. So we're snake body slithering. When we add a body, a child. So now let's add a second one, and let's not slither. Okay, so we're staying still. As a matter of fact, no, let's do this. What we're going to do is we are going to slither, but we're going to slow down our snake to be like 1. I think it's like, if I do 1 right here, it's going to go super fast, isn't it? Yeah, so I'm thinking this needs to be 1/60. So if I go to my snake, and for the can, this needs to be that divided by 60 point. But the problem is that's an integer. It's like doing int division. So I guess I can go float equals 0. Let's go to game settings. We're going to make this snake speed a float 1.0. Over in snake, we'll make this 60.0. So like 1/60th, right? So if the time ticked is greater than 1/60, which is definitely going to be the case. Yeah, this thing's not going to work. Yep, let's get rid of this add body. Let's just make sure this works. I think my math is wrong. So 1/60, that's fast. If it's greater than 1/60, yeah, this thing's just, we're not even going to see it. Yep. That's ridiculous. Okay. So this needs to be, let's try 60 over the value. That'll work. That's what I actually meant. Yeah, this should do it. So 1, 2, 3, see, like 1 time a second. Now if we want to speed it up, we can say game settings. Let's do, like, say we wanted it to move once. Let's do like 10 right here. This would be every 10/60ths of a second, or 5/30ths, or 1/6. Duh. See that? Cool, huh? I know you guys are pumped. Whoever's watching this at whatever point in time. But let's make the snake speed 1. So that it only moves 1 at a time, because what I want to do is inside of my snake, when we add a body, let's add a second body, now we need to go else body equals, well, this kind of depends. So if, based on the direction that we're going, we need to add it in that direction. So we need to say, like, if, let's say, tail dot next direction equals, I don't know, float 3. If we're going, let's say, backwards, so -1. Actually, let's do 1 because that's the actual direction we're going first. 0. If we're going in that direction, then we need to add it -1. So we need to say body equals snake body, and then the next direction is going to be whatever the tail dot next direction is. So the tail's going down. We obviously need to go to where that tail's going. And also we need to go body dot set position. We're going to get a, body dot set position to a float 3. Actually, well, this is position X in this case because we're talking about the X-axis. To the tail dot get position. So instead we could just say body dot move. No, we'll do dot get. So we'll get the tail's position plus the tail dot next direction. The inverse, the negative. All right. So this probably won't work. This is kind of thinking of math on the fly. Math is fun. Yeah, so the body dot setting the position X. We don't need to worry about the Y. Seems to be underscore tail. Don't need to worry about the Y because we're going in that direction. We're never going to add it above or below. All right, to type float. Tail. Oh, set position. This needs to be just total position. Because anywhere on that grid. Oh, and this needs to be tail dot next direction divided by Yeah, oops, this isn't gonna work. Yep, so this needs to be tail.next direction divided by game settings dot width. Is that wrong? That's got to be wrong. If this works, oh my god, oh my god, oh king. But now, oh, look at it go. Okay, so that wasn't that hard. See? See? It's a snake. It's a snake. Okay, so yeah, we can add like bodies now. So add body, add body, add body. Got 3 of these little bastards. Let's watch. Let's see. Three little body parts moving to the right. Oh, okay. So the one thing I didn't do is I didn't set the tail equal to the body. Because it's still using that head as the tail. So right before we add the child body, I need to go self.tail equals body. And I don't need to do that right there because it's going to do it already. And this should give us our snake. Okay, so our snake's only moving in one direction, but that's fine. We can still move the head in whatever direction we kind of want. I'm going to push this code up so you guys have it. Actually, let's add some terms real. Well, no, let's add it. So, adding body parts. Can you see the snake game yet? Is it snake yet? We only have 20% of my battery left, so we're going to go as far as I possibly can. I need to add one for every single one of the directions. So up, down, left, right. So we're going to say 0. Let's just make all these zeros first. All right, so this one is going right. This one is going to go left. So if we're going -1, this one will be going up. So if we're going +1, this one will be down. So if we're going -1, we don't even need that Z. We still need the tail.next direction. This does not change. But where we add it is important. So I guess like since this is copied like over and over again, so what I can probably do is just do that. Let's just, yeah. So now we have a body. Now we're just setting the position based on whichever direction it's going, right? So let's see. If we're going right, we're going to set it to the inverse of that. If we're going left, meaning we're going that way, we need to also, yeah. Wait a second. Am I going nuts here? Because this looks like it automatically works. So I'm just gonna do that. All right, we're just gonna see what kind of magic I just did. Because I'm thinking the tail, it's just gonna get the next. Yeah. Let's go down. Let's set the next direction as going -1. Let's try that. Huh. Okay, well, I guess I'm just a silly duckling. Amazing. Look at that. Oh my god, it just works. That's cool. That's not how I built it originally. We probably will need to do stuff based on that direction. What do we need to do? Nothing? Alright. I guess we don't need to worry about that right now. So now that we have that, let's give this thing the ability to turn. Okay. Now how do I explain this to you? I'm going to start it up. Let's see. So, I think so. Somebody's at my door. They might not be at my door. Okay. This is live. If something happens. All right, so let's talk about where these things turn. So the way in which we turn is based off of the head. So in this case, this is the head of our snake, and wherever our head is, say its next direction right here goes to this point. Well, what we can do is in a dictionary, like a lookup dictionary, we can set this grid position, whatever it is, equal to like a turn, and in what direction, so that when this tail spot gets to this square, it sets its next direction to that direction in that dictionary. So we can just do a lookup, say if this current position in that dictionary exists, let's turn in that direction. So it's super easy. It's like a pretty easy concept. Yeah, let's implement it and see if anyone has questions. Nope, no questions. So let's make this snake turn. Okay. The first thing I do need to do is I need to keep track of the grid position of the snake. Like right now, we have like a position on the screen. We don't actually have a grid position. If it's at, I don't know, let's see, 0, 0, yeah. So we can do this. Okay, we can do this in multiple ways. The way I'm thinking about it, we can do this in multiple ways. The first way being that this top left is 0, 0. This bottom left is 0, 0. Top left is 0, 0. So what I'm going to do is this square right here on this grid is going to be 0, 0. And this bottom grid is going to be grid width, grid height. Does that make sense? Good. So this will be 0, 0. So right now the head is currently at 0, 1, 2, 3, 4, 5. And then, 1, 2, 0, 1, 2, 3, 4, 5. So it's at 5, 5 on, is that 0, 1, 2, 3, 4, 5. It's at 5, 5. Cool. It's at 5, 5. So it should have that as its, oh man, my computer was unplugged. I don't know. We might be able to get the turns in. We can get the turns in. If this dies, I'm so sorry. I will be back. But thanks for watching. Oh, I need to get my battery fixed. Okay, so if so this is 0, 0. This is currently 5, 5. So right now, the head should know that its current position is 5, 5. And how do we do that? Well, that is going to be some magic. So over in grid, I need to create a function. Okay? And what this function does, I'm not going to put it up there. What am I doing? What this function does is it basically returns the position in grid coordinates. Okay? So I can call grid.getMyPosition in grid coordinates. Is that a good way of doing it? So 5, 5. So check this out. This is what we can do. Let's not do it that way. There's an really easy way to do this. And that is to go back to our snake and let's go snake body. We're going to say var position, and that's going to be a float too, because I don't feel like dealing with like uint 32s. Should I do it int 2? Is it like an int 2? Yeah, we have an int 2 here. Does that work? Grid position. Yeah, so that obviously works. So I'm going to go private var grid position underscore grid position. I'm going to move that down to right here. And what I'm going to do is every time I slither in a direction, right? What direction do I slither? Well, it's either -1 or +1. And so what I can do is down here where I do slither, I can say grid position. So I can do let position, let new grid, we don't have like an XY for our float 2 or float 3. We can't do like float 3.xy. So what I can do is I can just go grid position minus equals, or plus equals, excuse me, plus equals. We're just going to do that. Float 2 self dot next direction dot x self dot next direction dot y. Okay, so it's just gonna do that, and obviously we can do that. So the grid position is gonna increase and decrease by int 2. This needs to be an int, I think it's actually a uint, or like an int 32 or something. I'm gonna try that, see if it works. Grid position shouldn't be in float. I was gonna do it in float, but plus equals is not good enough. So, and I don't feel like doing like an operator overload. Yeah, so this isn't that hard actually. Self.grid position equals, we'll do self.grid position plus. I know this is getting a little ugly, but I don't care. And this will be self.grid position y plus next direction dot y. And then we're going to print that thing. What are you talking about? Ah! I wonder if that was the issue to begin with. So grid position dot x plus int 32. Yeah, I need to take this and put it in front of there. Hope this is interesting. Like I said, if you have questions or you just want to make crazy comments, you let me know over here. Oh, what's up? What's up, Peter? Welcome back, bro. Getting this snake thing rolling again. Yeah, so now every time we slither, I'm just going to print self.grid position. And just to kind of make this work a little bit, let's do 5, 5 to begin with. And I'm not going to add extra body parts. And I'm going to remove, and I'm going to add slither back. So down here in the bottom, we should see first 5, 5. Well, then we should see, y-axis goes in the other direction. Okay, so the y needs to be minus. Because the next direction dot y, say we're going down, like going downwards, well, the top left is 0, 0. We need to be increasing. So if our grid position y is at 5, and our next direction is -1, we need to add those, so negative and negative. Get that? Negative and negative. Oh, I know what I'm talking about. I'm not going crazy. All right, so what we're going to do is we're just going to move this over. We should see 5, 6, 5, 7, 5, 8. If I go to the left, it's going to go, see that? Oh, let's go to the top left, and it should be 0, 0. All right, this is going to take some time. 3, 2, 1, 0. And then if we go all the way to the left, it should be 0, 0. Boom. All right. Then it goes negative. And we can do some stoppage. But yeah, there we go. All right. The problem, though, is that this is 5, 5. Like, I'm hard coding this just for the head, but every single body part that we add for this is going to be in a different location. We can't just hard code it to 5, 5. But what I can do is just like do a set grid position every single time I add something. So what I'm thinking is func set grid position. That will take in, I mean, we can do the int 32, which is the, I don't know, tail position. It could be whatever position, set initial position, initial grid position to pause int32. And then go self dot grid position equals pause. That's not so bad. Not so bad at all. This is an int2. And then what we can do is we can just say, because we could do math. We can literally just do some math, like divided by, and I did math in my other snake one, but I want to kind of prevent that. We could just like get the grid position based on our current position on the screen. I mean, what does that look like? So if I were to go right here and comment out this grid position thing right here, and instead do like self dot print get position. Right? If I have a position of 0, 0 on the screen, then I know that I'm in like 5, 5. You know? What is my positions? Yeah, and these are just, yeah, so, yeah, let's do it that way. So get position, if I want it to be at like 5, 5, I would go get position divided by, well, it would be this. It would be, let's go print get position. Let's just, screw it. I'm going to go to my other snake game, because I've already made this math, and I'm not going to do it again. It took kind of a little while to figure out this math. I wanted to prevent it, but it's just a lot nicer. Let me see if I can go down here. Screen position right here. Get screen position based on grid position X, grid position Y. That's just the screen. Then we have set initial. Don't peek. Stop peeking. Set initial value. Screen position equals screen.get screen position. Where the hell do I set this grid position? Oh, here we go. So this is how I increment it and decrement it. That's pretty cool. Snake section is what I called it in this one. Where did I even put? Look at this. This is ridiculous. I have this grid position X. Oh, it's probably a part of game object. Huh. So my game object. See, this is me just playing and not thinking. That's what I get here. So grid position X, grid position Y. I must set those at the top level. See, this is just terrible coding. I'm ashamed of myself. Let's see here. I only have 11%. Might not get the turns in today. We should, in the next 5 minutes, have a turn. I'm trying to think. So we have the snake, and when we add a body part, see, this is what I was talking about. Look at that. Oh, good God. Get good at this game, please. Sorry, guys. I'm just... Next direction. I'm trying to figure out where the hell I set this freaking... We have this grid position X. Alright, copy fine. There we go. Where do I set it? Section cell X. Okay, so when I create it... Aha! I just pass it in. Huh. Has there ever been an easier way to do that? I don't do set to anything. I just pass it in. And then when I move... I do that. So we'll do next direction. We'll do cell X int 32, cell Y int 32, next direction. So now when we add it as a cell, we have a grid position. So I will say self dot cell X, or grid position dot X, equals cell X. Self dot grid position dot Y equals cell Y. And then now it's constructed at a position on the grid. Amazing. Amazing. We need a couple things here. I'll do let tail grid position. See, You monkey. This is where that next direction stuff comes in handy. I'm at a loss for words. Sorry, guys. I'm not trying to make this ridiculous. Let's see. What do you guys have to say? Maths. Yes, indeed. We're going to get this. We're going to get through this. So I'm going to add these right here. Fix that. It also needs a cell Y, which needs an int 32. So let's say 5, 5. That's just adding that. And then we're going to go here. We're going to get through this. We're going to have a freaking snake moving. And we're going to add bodies, but we're not going to do that yet. So now, every time I tick, I just want to make it easy, you know? Is this easy? I wish my battery wasn't dying. I'd be able to do this a little longer. If we can track the grid position, it shouldn't be that far off from... So there we go. 8, 9, and 10. Okay. So that's working. We're just going to initialize it like that. And then based on whatever direction it's currently going, right, we can just say that's what the next position is. And we just multiply it by, oh, that's a good idea. How about that? We can go var next, or how about grid position equals, we'll go int 2, we'll go tail dot get. So this is no, dot grid position. Is that not a thing? That's private. We're gonna have a get here. Get grid position. I don't know why. This is gonna be it's a variable. Sorry, I'm getting a little sleepy. I wanted to put something up. I don't want to just like leave this hanging and not have a snake game. I've been meaning to just show you guys what the hell I'm doing here. When we add this, we're gonna get the grid position dot x. We'll just do tail dot get grid position. Tail dot grid position. Now we can multiply it times based on the direction, right? So if I go times or plus int 2, oh man, this is gonna get crazy. This is gonna get crazy. Tail dot next direction. So we got the tail dot grid position plus or minus. All right, let's say. All right. So say we have a head, and inside of that head, we're going to the right. We know that the next position is going to have an x and then -1, because right here we do this. So all I really need to do is say grid position plus equals the inverse of this. But I can't do that because next direction is a float. So what I have to do is I have to go int 2 tail dot next direction and dot x, and this will be int 32 comma int 32 tail dot next direction dot y. Close it, save it, see if it works. Doesn't break. Okay. Oh, minus equals. So we can't do that, but we can go minus equals, just like so. It doesn't run because it doesn't like that. Does not support checked arithmetic. Using that instead. Okay, but like I said before, we can just go grid position dot x minus that on both of them, except this one's going to be y. Who's satisfied? Anybody? Now let's print this grid position. Print grid position. As a matter of fact, I'm not going to do it there. I'm going to print the tail's position, because that's really what I care about. The head keeps track of its position just fine. Is ambiguous without more context. I was thinking the same thing. I was like, this is a very ambiguous number. Let's make it difficult. Yep. The same thing I did before. Right there. It needs to go right there. And this, because these are already in 32s. Those are not. Let's get a build succeeded. 6% left. Tracking grid position. And then that one. Yep, cool. So now the grid position can go at the top, and I can say grid position dot x, grid position dot y. Oh. Plus x. X, this one increases. Y decreases. All right, so that's fine. I'm at 6%. This thing's going to die. But if I were to instead, in my do update, let's just print tail dot grid position and hopefully run it. And we should see the tail probably at 5.4 first. Oop. It's doing some crazy printing. I really hope this works. Oh. It's not happy with me. Okay. There. That's already added that tail. We've added the snake body. Probably just going to add that at like the grid width divided by whatever. We'll figure that out first. Cool. So now as we move down, 9. So the y-axis is going too fast, which means that it needs to be plus. And I think the x needs to be subtraction. Oh, who is satisfied? Everyone? Who's out there? Anybody out there? Is that Peter? Peter. It's gonna go, man. This is it. This is the one. 6, 7, 8, 9, and freaking 10. That's awesome. That's great. That's fantastic. So now each individual body part, so now if I have this body, it should start at 2, and then it'll go to 3, then 4, then 5. So it should start at 3, 4, 5. That's the first ones we should see. If I'm not going crazy. But I might have to leave it here. We want this snake to turn, right? But I ain't got no battery left, so sorry. It's gonna go. It's just very slow right now. All right, cool. So 3, 5. So once that back gets to the bottom, it should be at 10. 8, 9, and 10. Cool. All right, so now we have grid tracking. The last thing I'm going to do, just because I want to get started really quick next time, is under the snake body, I need a var, as in grid position as string. And what this is going to be is basically the key for the dictionary. So I'm going to go return self dot. Now we'll do quotes. That. We'll go grid position dot x, comma. I'm gonna put some right there. And you guys are gonna get this code if you want to go try it out before the next time. I'm going to California pretty soon, like go visit family and whatnot. So I won't be on. I might record from out there. Never mind. It just depends. We'll see. I'll probably be on. I want to get this done for you. I know it's been a lot of just watching me code, but I'm problem solving this. Hopefully that's helpful to see that. Now if I say tail dot grid position as string, if I print that, it should just show me basically an XY. It shouldn't say simd that down there at the bottom. It should say the actual string of the grid position. And let me make sure that I'm doing, yep. And so that's basically going to be the key. So when we get to that point on the grid, we can just do that grid position lookup. Pretty cool. So now, yeah, you see it's printing down there. And I'm just going to remove this space, run it, and this will be as far as we go during this episode. So I hope you guys enjoyed this episode. Sorry for being so sleepy. It got kind of late. It's 9:30. And I worked all day. And I just smashed at Rocket League, almost champ 2, no big deal or anything. Yeah, so now that it's printing out just like so, and I am satisfied. So I encourage you to create a dictionary and add that turn and then set the turn in that for loop for when they do the lookup in that dictionary, set that turn on that object, and then you'd have to remove that turn from the dictionary because it'll just stay there, and then every time any cell gets there, it's just going to turn, so it would never be removed. So if you get to the tail, then remove it. Anyway, we'll do that next time. We should actually have a snake wiggling around our screen. Hope you guys enjoyed this. Welcome back, Peter, dude. You're a champ. You stick around all the time. Much respect. Some of that for you, Peter. Yes, I know. Hope you guys enjoyed that. I'm going to end the stream now. Yeah. Peace. Yeah, let's end that stream.